So today we will be reviewing the NanoDrop Ultra double-stranded DNA Broadrange Fluorescence Kit. The kit is going to be supplied with a solution of buffer, a 200x solution of the dye for the fluorescence assay, a standard 1, which will be 0 nanogram per microliter in TE buffer, and a standard 2 at 100 nanogram per microliter. So we have two samples that we have already extracted and purified, and we are going to first come over to the NanoDrop Ultra instrument. We're going to click in the Fluorescence tab, Reagent Calculator, and here is where we have the option to select our assay. We are working with the double-stranded DNA broad-range assay. Our sample to reaction volume we know is going to be 1 to 10 because we already looked at the absorbance of the samples prior to starting the fluorescence assay, so we know what concentration the samples are approximately. We're going to enter in that we have 2 samples, 2 standards, and we would like to include overage. Now, this reagent calculator is going to tell us how much of the 200x dye we need to add to our buffer. So we know that we need to add 1 microliter of dye to 199 microliters of buffer. And this is going to dilute our dye down to within a working solution concentration. To make our working solution, we are going to start by pipetting 199 microliters of buffer. And we always recommend working in amber tubes for fluorescence assays. And then we are going to pipette 1 microliter of our 200x dye into that 199 microliter of buffer. And we will do a quick vortex. We are going to pipette 18 microliters of our working solution into each of our standard and sample tubes. Now that we have our working solution in the tubes, we are going to add in our standards and our sample to each tube. And both standards and samples are going to be added into 2 microliters. My samples and standards are pre-vortexed. So the samples and standards are homogeneous. And now I'm going to quickly vortex and do a quick spin before we start incubating. We are now going to set a timer to incubate for 2 minutes at room temperature. Now that our timer is up, we are going to measure our standards and samples. So if we close out of the reagent calculator, we can select the application double-stranded DNA fluorescence. The pop-up window is going to ask us how many replicates we want to make. Our protocol suggests that we measure 5 replicates. Our sample to reaction volume is 1 to 10 based on our sample concentrations. And we are going to save this, and we are ready to measure standard 1. We always clean the top and bottom pedestals with a lint-free lab wipe. And we are using a clean pipette tip with each measurement. The on-screen prompts will continue to walk us through what standard we need to measure. Okay, and now we can move on to standard 2. So now our standards are complete, and on the screen, there is a prompt that is telling us to click next to proceed, and then we can review our standards to see if there's any that we have to remeasure, or we can start measuring a sample. So we can click Next. And then to review standards, you can either swipe or you can select the circle on the bottom of the screen. To review your standards, the remeasure button is going to be the play button with the arrow. Looks like all of our replicates are all in agreement with each other, so we don't have any to remeasure. So we are going to either swipe to the next screen, or we can click the circle on the bottom. And at this point, you can come to the top of the screen and change your sample name. I'm going to keep sample 1 because that's how I labeled my tubes. This button next to the measure button, this is auto measure. So this means it is enabled, and auto measure, it's going to initiate a measurement right when we lower the arm. If you want to turn off auto measure, you can see that the icon is a dark color now. That means that if we lower the arm, a measurement will not proceed until we click the measure button. So let's keep auto measure on, and then we can start measuring our samples. Again, I do recommend measuring 5 replicates. So all 5 replicates of our sample 1 are completed, and we can see at the top where we have the sample name that there was a count that was going up next to the sample name. This is our auto naming feature. This makes it much easier to follow how many replicates you've measured, but it can always be turned off by coming into the settings icon and deselecting auto naming. So now that we're on sample 2, I'm going to change the sample name to sample 2, and you'll see another a number 1 appears, and that means that's the first replicate that's going to be measured. Okay, now that all of our standards and samples have been measured, we are going to clean the top and bottom pedestal. We are going to click End Experiment. And here is where you can change the experiment name, add any tags, click Next. And then we have the option to export the data or end the experiment. If we click Continue, we have the option to export data, USB-C on the front or USB-A on the back. And you can export as a .tsv or .csv file, or you can export as a NanoDrop Ultra experiment data. This allows you to open the data on your PC, and you can select the elements that you would like to add. If you want the application name, which is double-stranded DNA broad-range fluorescence, the instrument serial number, report data, which is all the data that is saved on screen in the report, and the spectral data. So if you want to look at the emission spectrum, make sure spectral data is turned on. For the report, you are able to save the document as a PDF, and you have all of these options to select or deselect to include in the file. If we select Preview, we can see what the PDF document is going to look like.